All right. It's about 40 minutes before class time. And I think I'm going to try to use about 30 minutes to talk about major topic. Got a marker, got an eraser. All right, so solving equations. Tomorrow's your first test of the term. And really it's a scrimmage. I just want to see how you're doing. Your grade really is going to come from tests near midterm when you've had ample opportunity to make mistakes over the course of the semester, learn from them, and then show me that you have some literacy with the calculations that we're considering. All right, but I want to group a major topic. You know, we graph, we evaluate, we solve, we have specific skills, and that's what math's about at this level. And so solving equations is one of the major things we do during the term. So I want to get a sense of how to group different types of equations and what the easiest ways are to solve. The majority of equations have just single variables, major operations, ln of x, e to the x, square rooting, squaring, multiplication, so on and so forth. There are major operations. And what I think you'll discover is you can solve all of those basically the same way, using inverse operations. And those inverse operations come from the reverse of the evaluation process. And so we go from hard to easy. So the inverse is easy to hard. And what you'll find is that you're basically taking care of addition and subtraction, moving into the other side of the equal sign, and the multiplication and division to the other side. And then the major operation usually appears. And you have to know what the inverse operations are of ln e to the x, exponentiating, logging, square rooting, cube rooting, roots in general, powers, multiplication, so on and so forth. But once you get the hang of it, they are very quick and easy. Boom, 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 you're done. There are other types of equations that pop up in math because of the history of the evolution of the discipline. We start getting into higher order polynomials, and the variable is appearing in more than one term, and they're not like terms, otherwise you'd be combining. Right, so the question is, are inverse operations necessarily the best way to handle that? Well, no, because you have to change the form into those inverse operations. Sometimes it's helpful with a quadratic because it's quick and easy, but by and large, other methods come into play. And where did those methods evolve from? The history of the discipline, right? Rectangles, length times width equals area. It stands to reason that user-friendly numbers are helpful because length times width equaling 0 implies that either one of the dimensions has to be 0. If you get rid of a dimension, you get rid of for instance, getting rid of length here gets rid of the area of that rectangle. So it's an important skill to learn how to write products, and we've been practicing that on every worksheet. Theoretically, coming out of Algebra 1, your factoring skill should be much stronger than they are. Okay, what's the reason for them not being stronger? I don't know. People aren't doing enough of it. I imagine people just aren't doing enough of it. Well, we're going to start at some point to do a whole bunch of it. It's a skill that should be in place already, but we're going to have to get it in place while tackling all of the other Algebra 2 concepts, which are going to come into play soon. E to the x, ln of x, general exponentiating and logging. All right, so let's get back to the topic at hand. Solving equations. So let me do them. I think I'll do some here for you. So let's pick one and see if it follows the add, subtract, multiply, divide. Let's solve, which one of those is a good one for you to solve? Let's solve something. Let's solve a quadratic. 2 times x minus 3 squared plus 4 equals 5. Okay. I hope it makes sense that the change is occurring here, right? Plus 4 equals 5. Well, it makes sense that this has to equal 1. Well, how do we see that? Let's see, get my eraser out here. I think if I come over here, it's a little easier. Addition becomes subtraction, and we have 2 times x minus 3 squared equals 1. Does that make sense? I hope. Yeah, we got rid of addition of 4 with a little subtraction on the other side. All right. This is the major operation right here. That's the major operation. And it looks like 2 times whatever numbers come out of this have to equal 1. Well, it sure seems like 2 times 1/2 will definitely equal 1. So what do? We take the multiplication, we move it to the other side as division. There we have it. And now we are at the inverse operation of the major operation of the problem, which is squaring. And you have to learn, and it takes a long time. And the only way I've ever been able to teach students in a class is to give 2 weeks of make your mistakes, and then I sneak up behind you and I go, I scream back in your head. And then the class jumps. They go, you forgot to write plus minus. So plus minus the square root of 1/2, which happens to be, not that you've had it yet, you haven't. But that's equivalent to plus minus √2/2, which I'll be asking you to memorize for your trigonometry. It's useful to know that as a decimal. Might as well tell you right now, it's approximately 0.71. So you've got plus minus 0.71. We'll talk about that later in the term. Right now, you're here. The inverse of squaring is plus minus square rooting. Okay, and now we're back to multiplication, division, addition, subtraction, which could be reversed at different times. We've just got a very simple what minus 3 equals. This actually is useful to talk about a little bit more. Plus minus the square root of 1/2. Well, one thing for certain, the number 3 doesn't work here, right? So we can get rid of minus 3 by plus 3. And let's see, I'm not talking about this as well as I'd like to, so let's just simplify it and say subtraction moves to the other side. I'll talk about this in greater detail in another video. It deserves more chat, and I want to get it right now. All right, so that's using inverse operations, and it generally follows this form. I'll do the square root one. And to show you that, there's 2 ways to look at the inside of that square root. So let's solve 5 times the square root of 2x minus 1 plus 9 equals 28. Again, the same issue here. What plus 9 equals 28? Well, it's got to be 19. So hopefully it makes sense that we're going to get rid of addition with some subtraction. 19. And if 5 times something equals 19, then I guess it's got to be 19/5. So what's the next step? The multiplication becomes division. Okay. If squaring gets you 19/5, then I guess we need 2x. I guess let me do it numerically. I guess we need 19/5 squared, right, to undo that operation. So that is the inverse of squaring. Square rooting is squaring. And we don't do plus minus. We'll talk about that at greater detail later. So we're here right now, I believe. So therefore, 2x minus 1 equals 19/5 squared. Okay, now what is that as a decimal? I don't know, I go to a calculator, right? But right now, that's the number that we've got in front of us. And now we just did the inverse of square root. And you need to know the inverses. All right, now, this could also have been written as 2 times x minus 1/2. Right, that's how I put it. So I can really talk about division next, and then subtraction becoming addition. But it's much easier if we simply do what here? Get rid of subtraction with addition, just like we did at the start of those linear functions over there. All right, so that takes care of, I'm sorry, minus 1 becomes addition of 1 on the other side. And whatever this is, whatever this thing is, Dividing by 2 isolates the x. Okay, so it kind of follows the addition, subtraction, multiplication of the inverses of addition and subtraction, inverses of multiplication and division, major operation to get at what's inside. That's the general idea of solving equations when the variable x only appears once in an equation. I'll do an exponentiation. So let's do the 7 plus 2, 3 to the 5x minus 2 over 9. And let's set that equal to 100. All right, and I'm just going to do this in a very quick slash and burn exercise. All right, so I'm going to subtract 7. 93, I'm taking care of that operation. I'm going to divide by 2. 93 over 2. I am now at the major operation of exponentiating. That's the major operation right there. What's the inverse of 3 to the x? Log base 3 of. So to get rid of this, I'm logging, I'm trying to find the value of an exponent that I put on top of 3 to get 93 halves. Obviously not friendly numbers right now, but it doesn't mean I'm not on the right trail. All right, so that takes care of that. So what do we have next? Division becomes multiplication. All of this would have to be done with a calculator to get a decimal answer. That takes care of that. We're going to subtract 2, so we're going to, so you can see that, add 2. That takes care of that. And multiplication by 5 becomes this whole thing divided by 5. And what I'm suggesting here is we're going to practice this mindset of inverses. We're going to talk about it the whole semester. But keep in mind, we can't always do that, especially with cubics. Very hard. You can write these in graphing forms, but x is going to appear in 2 places. These are slippery critters. Okay? But initially, as this discipline was evolving, it was about geometry. It was about, can we write these functions as geometric shapes that are user-friendly? And I'm talking about what you should have solved in Algebra 1, tons of, you should have done tons of x squared minus, let's say, 4x is equal to 21. Should have done tons of those. Step what? Set it to 0. If you set it to 0, you've got x squared minus 4x minus 21 equals 0. And you should have done a lot of expanding to get these trinomials, x times x, 2 numbers that multiply out to be 21, that are 4 apart, needing it to be negative. Okay, this is the stuff we've got to practice a lot so that we've isolated some x's, but it's shown as a product. And so we can see our answers, and that's what we've got to practice. These can come at us in the form of quadratic equaling a line, and we've started to graph those in class too. But my suggestion is pay close attention early on to these problems, think about them long and hard, and then once you learn how to do them, then the rest of the time you work with them, you should be able to do it effortlessly. I like to solve this by, well, obviously your first step is always to get your x's on one side of an equation, right? And it appears twice. They're not like terms. This is to the first power. So what is one way we can get to easy solutions? To write it in factored form, to write it as a product, and then one of the dimensions or the other. Right, solving that then brings us back to inverse operations. You get your 2 answers. So writing products is going to become very important to us. Learning how to construct different situations for some user-friendly values. And when they're not user-friendly, I know this is a 19 equals 0, a problem like that. It's not user-friendly. Can't really write that as a product right now. I don't think anyway. I hadn't thought about it long enough, but I doubt you can. That's why you have things like the quadratic formula, which I very rarely use anymore, except for the discriminant. I generally don't use it too much because high school math, we're basically working with user-friendly numbers. Like completing the square types of equations, but it's useful for a problem like this. Would it be the quickest way to solve that? And I'm just thinking, would it be easier to do this 1/2, right? 1/4. So it would be -1/4 squared. Is it worth it to get the constant over here and then use inverse operations? I generally work in that form, but I might go back to the quadratic formula for something like that. Anyway, I wanted to just get some general sense here of what we're doing to move to the quadratic. We mean adding another dimension here, right? And all it would mean is, you got one more dimension. And so maybe an x plus 5, something like that. I don't know. But we practice this a lot, writing things as products. Why? Because it was the easiest thing to see early on in the evolution of the discipline. I think we should move beyond this when tackling cubics. I think there are other things that are far more important to discuss. But it's still in the textbooks a heavy exercise. And so we want to be able to understand the significance of products, work with products. We'll work with this graphically. We'll look at inequalities. It's an important topic and we've got to develop it. But right now, we're basically just solving equations using inverse operations and doing some basic factoring. Now, one nice thing about cubics and quadratics is there's a topic where we can maybe look at 2 plus or minus 3i. We'll be generating those answers in class. Bring it over here a little bit. We'll be generating these, and there are easier ways to find what equations created these than the textbook method. Textbook method works with factors, heavy on the factors. But these types of equations give you these types of answers. And look at this. We want 0 on the right side. Well, there's nothing preventing us from moving the 2 to the other side. We still have something here, but we certainly know that we want quadratics. So x minus 2 squared equals plus or minus 3i squared. That's one place we're showing the same operation on both sides. It's useful. What we get here is x squared minus 4x plus 4. We're getting better at squaring binomials quicker. This is 9i squared. We know 9i squared is minus 9, so we can just move the minus 9 to the other side. And we can get ourselves x squared minus 4x plus 13 equals 0. Actually, understanding that and practicing it for a few days, you can get your answers in under 5 seconds when you understand the mechanics of this. So we will be doing some work with variables, a couple of variables, non-like terms on the same side of the equal sign, and taking advantage of what we learn over here with inverse operations to make some problems much more, to be able to work with some problems more quickly and easily. And that's why I put effortless effort takes effort on the top of every one of your tests, and you'll be seeing that tomorrow. All right, so in class today, we're going to work on a variety of the newer topics. See you soon.